All right. Matrix formulation of linear systems. So we're going to have a linear system and we're going to be able to make matrices out of them, just like we could with regular linear systems. Yes? And so it says a matrix function, we're going to call it A, taking real numbers into some n by n matrix is given by this guy, which there are typos that we're going to fix right now. I didn't catch these before. It's an m by n, so the rows should have been m and then the columns n. So that's a away with it with just, come on, oop, well, it erased too much. Doot, doot. Okay, we're going to fix these. This is going to be the m row first column of t, and then the mth row second column, m2, am2 of t, and then this would be the m row n column. Hopefully that makes sense. Okay. Where each of these aij's are taking a real number to a real number. They're all real functions for all a, I, and j. One example, this is just an example of just a matrix equation. An example of a matrix equation where you can just make a matrix out of, they're all functions in there. So these are all these a11 of t, they're all functions of t. And then a first order linear system can be written as a matrix equation. X prime of t is equal to a of t times x of t plus b of t, where your x's are this matrix of just these x's. X prime, here's some more typos. It should have been, each of these are x prime, x prime, x prime. They're all the derivatives. A is this guy up here. So again, more typos down here. Sorry about that. Thought I caught all of the typos, but apparently I did not. Okay, so first column, this would be the element in the m row m column 1, and then of t, and then this one would be the m row m column 2 of t, and then all the way through, this is going to be row m column n t. Not that it matters, but I like my notes to be proper. Because it's not like I'm going to be memorizing these, but they're just representing each of the things. And then B of T is some other matrix here. And so we are going to be, let's do an example where the first one, all we're going to do is given that A is this, here's this matrix function, right? And then B of t is this. We're going to write x prime equals a times x plus b as a system of differential equations. Okay, so let's do that. This is, I should have written the title first. 6 for matrix formulation of linear systems. All right, so first example is given that your matrix function is t squared 1 negative e to the t and then cosine of t. So they're all functions of t. And b t is 1 minus t. It's a 2 row 1 column matrix, right? Where it's 1 minus t on the first row, and then, so it's not, anyway, hopefully that makes sense. All right, and they're asking us to write the derivative of x is equal to a times x plus b as a system of differential equations. All right, so first thing I'm going to do is I'm going to let x represent the matrix of x1, x2, 2 rows, 1 column, and then plugging in to this guy, x prime is equal to a times x plus b, would mean that I've got x, the derivative of x is equal to a is t squared, and then negative e to the t, and then a 1, and then a cosine of t, We're going to multiply that times vector x, which is just this matrix, this column matrix of x1 plus, or x1 and x2, and then plus this last column matrix, the b, and then 0, like that. All right. So that's the matrix equation. We plug in these guys in, but they want us to write them as a system of differential equations. So they want the individual equations. Well, we can do that, right? We can say x1 prime, because remember this vector is the column vector of, or the column of all of the x prime. So x1 prime and then x2 prime and all of that. So this is equal to, well, it would be first row times the column plus the first row. So remember how you multiply matrices is row 1 times column 1. So it would be a t squared x1 plus negative e to the t times x2 plus row 1 of this matrix. There's one equation. Our second one is row 2 times the column plus row 2 of this guy. So it would be 1 times x1 plus cosine t times x2, and then plus 0. There's your system of differential equations. Easy peasy lemon squeezy, right? It's what you needed after the last lesson is an easy one, huh? All right, how about example 2 says they want us to find matrices A and B such that the system can be written as x prime equals ax plus b. And the system they give us, so now we're working backwards, right? Doing the opposite of what we did in the last one. The system they gave us was x1 prime is equal to t times e to the t times x1 minus x2 and then plus 1. x2 prime is x3 minus e to the t, and x3 prime is x1 plus e to the t x2. Okay, so first of all, I'm going to let x, the matrix, be x1, x2, and x3, since we've got x1s, x2s, and x3s there. And then how you get matrix A, remember that this was, we got this, let me slide it down more. We got this equation by doing row 1 of A times the column of x and then plus b. Yeah, so that's what we're going to do. We're going to work backwards in this and say, all right, well, what does that mean? That means if I'm going to write it as that this guy, which by the way is x1 prime, x2 prime, x3 prime. It's that column. So I could write that. When I say x prime, I am saying x1 prime, x2 prime, x3 prime. I should have left more room, but hopefully that makes sense. That's what that left-hand side is representing. Okay, so we're going to do, we want x prime is equal to ax plus b, right? So I've got x is that. Well, then that means that your a is going to be, you're just going to take this first guy and whatever the coefficients are on x1, x2, and x3, whatever the coefficients are on those from these equations, that's what you're going to use as what you're going to plug into this matrix. So for the first differential equation, we've got on x1, it's t times e to the t. For x2, it's a negative 1. There is no x3, so it's a 0. Yeah, which then means anything without an x1 or an x2, that's going to be what goes into the B matrix. And so for row 1, it's just a 1. All right, then we go for x2 prime. All right, well, you don't have an x1, so it's a 0 in front of it. You don't have an x2, so there's a 0. There's a 1 for x3, and then we've got negative e to the t. For x3 prime, we've got a 1 as the coefficient on x1, e to the t as the coefficient on x2. There isn't an x3, so a 0 on the x3, and there isn't a term, like there's no constant or function, or it could be a function, it doesn't matter. But there's nothing after there, not attached to an x1, x2, or x3. All right, there we go. They just wanted us to write matrices A and B. There you go. Obviously, you don't need the x1, x2, x3 up there. I just wrote it to help you see where am I getting these guys from. All right, then let's do one more example. And that says, given that U is e to the t and 2e to the t, that A is -1, 1 to -1, and that B is 0 and 2e to the t. Squished that on there. We want to verify that U is a solution to x prime equals ax plus b. Okay, so first of all, if we're going to be using U, that means that what we're going to try to show, we want to show that U prime is equal to A times U plus B. That's what we want to show, right? That's what we're going to show here. Okay, so first of all, let's figure out what U prime would be. Well, it's going to be the derivatives of each of these functions. Derivative of e to the t is e to the t. Derivative of 2e to the t, well, that wasn't very exciting, but it is what it is. That's U prime. All right, so now we want to show is when I figure out A U plus B, it should be equivalent to this guy. So A is -1, 1, 2, -1 times U. We said U was e to the t times, and then 2e to the t, e to the t, and then we want to add that to B, and B was 0, and then 2e to the t. So what we want to know is, are these guys equivalent, right? Okay, so we're going to multiply this guy. Remember, row times column. So this is a 2 by 2 and a 2 by 1. So my answer will be a 2 row, 1 column. So it'll be a -1 times e to the t plus 1 times 2e to the t. And then row 2 times the column, 2 times e to the t plus a -1 times 2e to the t. And then we still have plus this other matrix. All right, well, I can just add these guys together. This is -e to the t plus 2e to the t plus 0. And then the second row would be 2e to the t minus 2e to the t plus a 2e to the t. And that will give me what? +1e to the t on the top. And on the bottom, a 2e to the t. And was that equivalent to this? Why, yes, it was. Check. Well, they were just asking us to verify, and we did. Not too bad, huh? Make up for yesterday's lesson. All right, I hope you're having a fantabulous day. Bye.